Hello everyone! We know I've been talking about this for a while now, but it's finally here. The process of how we reflow and build our boards using an electric skillet and sand. Yes, sand. Like from the desert. The actual desert. We will briefly go over the process of how a PCB or printed circuit board is designed, but nothing in depth. It's a long process and deserves its own post in the future. However, we will cover how to use a stencil, picking and placing components, the reflow process, testing a board after reflowing, and some hand soldering. And with that out of the way, let's get started. First, you have to start with the delicate and thoughtful process of designing the PCB, starting with a block diagram, then a schematic, and eventually a layout. Once all that is done, go to your favorite PCB manufacturer, upload the files, pray it passes inspection, and if it all goes well, place an order. Wait a few days, cheap out weeks, and congratulations, you have your board with hopefully no major crippling hardware issues. Hopefully. Once you get the board, you are allowed to admire and appreciate the work you put in, but not for long. Next, you gotta do a visual inspection. During manufacturing, some boards might have defects. Does it all look good and as designed? Are your vias placed in the correct places? Any silk screen issues? Unplated pads? Have a general look around. Once your board passes visual inspection, it is time for the next step, getting the board ready to have solder paste applied. Taping extra boards around the main board is the easiest method to ensure the main board doesn't move while we apply solder paste. Simply get extra boards, place them around the main board, tape them down, and check that the main board is firmly in place. Next, you have to check and make sure you actually have all your components ready and in stock. Each person handles it differently, but for us, we have an Excel sheet with all the parts needed to build an Atlas board, and exactly how many of each part we need. It is now just a process of checking the bags and placing them on the side to be readily available for when we need to pick and place. On to stenciling. Using a stencil is a very easy and cheap method to quickly apply solder paste to all the right places on your board. To get a stencil, you simply add it to your PCB order and have your PCB manufacturer make one for you if they offer that service. And now we are starting with the fun part of this process, applying the solder paste. Place the stencil on your board. Make sure it perfectly aligns with the pads underneath. Once you are satisfied, tape it down. The goal is to have this process go as smooth as possible without errors and avoid having to clean and start all over again. Once you have the stencil taped down, get the solder paste and plop it down. You can get messier, doesn't really matter. And yes, the pencil was the best tool within arm's reach that could allow us to spread the paste. It doesn't really matter how you get the paste there, make sure you cover all openings. What's important is using the right tool for spreading the paste. Our favorite is a regular card or anything solid like it. Simply swipe and scoop, reapplying solder paste that you collect to ensure all holes have been filled. Collect any excess paste and return it to its packaging. If you are new to the world of electronics, you might be wondering, what is this solder paste we keep talking about? Solder paste is powdered solder in flux paste. Try saying that 3 times in a row. Put simply, it's the thing that will eventually hold all our components to the board and form electrical connections between those components and traces on the board. Once all openings fill up with solder paste, slowly remove the stencil, making sure it doesn't slide and smear paste everywhere. And hold on, do not put that stencil away just yet. Clean it up if you're not going to keep using it. Trust us, hardened solder is not fun to remove later. Simply wet a cloth with 70% isopropyl alcohol and scrub until it's clean. It's a quick and easy process. Your future self will definitely thank you for it. Check out this solder paste spread. Nice. Now to a process we find soothing and relaxing. Put on your favorite music or podcast and simply vibe. What you do now is simply pick and place components in their correct locations. Don't forget to account for the orientation of components that need it, like diodes and ICs. In addition, components do not need to be exactly aligned on their pads. When you reflow, they will snap into place. And now enjoy the sped up version of us picking and placing components. And we are done. Check this out. Looks pretty good. Next, we move on to a critical step. Safely transporting the Atlas board to our quote-unquote lab outside. You got to be real careful when moving the board. Any accidental slip and you have to start the entire process all over again. Not like we know anything about this just yet. In this lab, we have 3 essential components. An electric skillet, yes, the same one used for cooking food. An infrared thermometer used to measure temperature from a distance. And of course, sand. We start off by covering the electric skillet with sand and turning it on. We use the IR thermometer to keep an eye out on the sand temperature. Ideally, it should be above 140 and below 200 degrees Celsius. We take the Atlas board and place it on the skillet. The solder paste we used is lead-free with a melting point of about 120 degrees Celsius. So, we try and keep the board above that but not much higher. We hear you asking, why sand? Well, sand helps with heat retention and distribution. Think about it, an electric skillet does not necessarily have an even heating area, and the sand helps mitigate that issue by providing better heat distribution and retention across boards placed on it, which in turn helps with the reflow process. Going back to the reflow process, a thing to note is it requires a lot of paying attention. You need to keep an eye out on the temperature and change the skillet's level of heating appropriately. Of course, one could make a device to automate this, makes for a fun project, or buy an actual reflow oven, but they are not cheap. The goal here is to keep the temperature as low as possible while being above the melting point. Using very high temperatures could damage the board and components on it. Alright, we'll speed things up. And as you can see, the solder paste is starting to melt and turn from grey paste into shiny, silvery connections. Definitely noise. Once all connections look good, we remove the board and allow it to cool down. Do not touch your board just yet, it's still piping hot. We embrace our failures here at Remal IoT in hopes others would learn from us. Do not, and we repeat, do not use the tip of a plier to grab the board and move it out of the skillet. Yes, most of the components flew right off as the solder did not have time to cool down and solidify. And yes, we had to do this entire process all over again. Everything from stenciling up to this point. But hey, no use crying about it. Plus, it's fun to build boards, so we quickly got back to it and had another board ready for reflow. Quick snippets from the new board being reflowed. And this time we made sure we have a proper tool to remove the board safely and carefully from the skillet. And would you look at that? Looking great. Once the board has cooled down, an important follow-up is to check the integrity of all the soldered joints. We recommend using a digital microscope to help with that process. They are cheap and can be easily found online. Next, check for shorts by using a multimeter set to continuity. Ideally, you would have done that when you first got the board and then once more after components have been soldered to isolate any potential issues early. Lastly, a quick check of the USB-C connection, and it lights up, looking good so far. However, we are not done yet. One final step remaining, which is hand soldering the rest of the through-hole components. Hand soldering through-hole components is pretty easy, and like the pick and place process, also very soothing. Here, we are reinforcing the integrity of the USB-C port. Since it will have a lot of mechanical stress, applying solder to hold down the connector is critical. The last thing you'd want is the USB port flying right off when you're working on a project. Terrible. Next, the buttons. We push them into place and solder down the pins. Finally, the screw terminal and any remaining headers. We'll leave you to enjoy these sped up shots of us soldering. Wallah, do be vibin'. And we are done! The Atlas board is now fully assembled and ready to be used. This, in short, was how we assemble and reflow our boards. We appreciate you taking the time to watch this and hope you learned something. Look forward to more projects, tutorials, and other cool things in the future. Do you have any specific topic you think would be interesting for us to cover? Let us know in the comments. And once again, thank you for watching.